Hello everyone, Shubham this side. So in previous sessions we talked about what is PKI, what is the need of PKI, the challenges in PKI, uses of PKI. Okay, but it was a general discussion. So from this session onwards we'll be discussing in depth for the concepts in the PKI. And today we'll be discussing a certificate. What is a PKI certificate or digital certificate or X509 certificate? And how to get it, how it is used, and all the details that are present in a certificate that we will also discuss with a live example from a site. So we will just go to a random site and we'll download the certificate the site is using and we'll uh, check all the components in that certificate. Okay. So now what is a certificate? So a PKI certificate, also known as a digital certificate, also known as an industry standard X509 certificate, it's an electronic document which is using cryptographic technology. Okay, so it proves identity for people, devices like laptops, computers, servers, then organizations, and secures the data through encryption and digital signatures. Okay, so it's a core component of PKI. The PKI is entirely based on the certificates itself. Certificates of any type, it's based on the PKI in its entirety is based on the certificates. Okay, it enables our communication over the untrusted networks like internet, and it secures our communication. So whenever you are accessing an secured site, it will be secured using an certificate, PKI certificate, if I say in uh, exact manner. Okay, so now let's move forward. So the, the first thing for certificate, whenever the certificate is there in place and it's working, that that thing comes in mind is certificate trust chain. Okay, so each and every certificate that you see or that secures a site or that is used for a user, that will be an end entity or leaf certificate, we call them. Okay, so that leaf certificate, it will be issued to user devices, websites, or applications, and those will be secured using that leaf certificate. Okay, it's in daily communications or daily end user authentication process, we use the identity or leave certificates, and most of the folks will be aware about the identity or leave certificates because those are in daily use. Okay, then we go to the its parent certificate, we can say, or intermediate certificate. That intermediate certificate is a certificate which is issued from root certificate and which issues the identity or leave certificates. Okay, so this works as an parent to our identity or leave certificates, and also it gives uh, a trust. It builds a trust with the identity or leave certificate that yes, this identity or leave certificate is issued from that intermediate certificate. Okay, then only that trust will build, and then only our certificate will work. Okay, and then we have the root certificate. A certificate is a self-signed certificate. So now what is self-signed? We'll discuss in later slides. So self-signed certificate, and it's the highest level of certificate chain. Okay, highest level in trust chain, and those certificates should be stored somewhere safe. Usually those are stored in an server which is uh, powered off most of the times to keep it from external what we say, any kind of disasters, like though it someone is trying to break in or someone is trying to steal some data. If they have their hands on the root certificate, then they can do it easily. So that is the reason that it is stored in the servers. Then servers are made offline most of the times to secure it. Okay, so how the trust chain works, like we will be having a root certificate, we will get intermediate certificates from that root certificates, and those intermediate certificates will be used to issue the identity certificates which we use in our daily lives. So it's an, you can say, a hierarchy or T diagram you can draw. It's like at the top we will have root certificates, intermediate certificates will be issued from that root certificates, and then the intermediate certificates will issue, or we will use those certificates to issue the identity or leave certificates that we use in our daily communication. Okay, now we'll see what are the types of certificates. Okay, there are a couple of types of certificates. based on the usage. Okay, so first one is the authentication. So there are multiple types in authentication certificates as well, just like user certificates. Okay, so user certificates by name, it suggests that it verifies the identity of the user, individual user who is trying to access anything. Maybe it's a server application, web application, a website, anything. So the user is getting authenticated with this certificate. It will be issued on your name, it will have your details, and those details will be verified whenever you're trying to access that concerned application site, website, or web application, anything. Okay. Then we have the device authentication certificates. It will be used to authenticate that device, that if this that's the legitimate device or not, then the accesses or the network access or any access to resources will be granted to that device. Okay. Then we have smart card certificates. Smart cards, as we know, this is another way to log into machines or laptops or computers. We are instead of using email and password for the sign in or using other pins, we use the smart card certificates or smart cards which will be having our certificates in those. And whenever that smart card is inserted into the device or machines, those will authenticate us using the details which are present in that smart card. It's a faster way to getting into your systems. Okay, and then we have the Wi-Fi certificates. So in most of the corporate offices, we can see that they will have their Wi-Fi setup. So whenever you are going into the offices, your computers or laptops will get automatically connected to the uh, Wi-Fi's or networks in the office. That is with the Wi-Fi certificates. Okay. Then we have the next type of certificates, that's web certificates. So this is the most common certificate that a lot of folks are aware of. This certificate is used to secure the sites, applications, anything. So most of the people know that whenever we are using HTTP, that means that there is no certificate present or that site is not secured. So whenever we are uh, using a certificate to secure that site will become HTTPS from the HTTP. Okay, so that one secure layer will be added, and this will secure the connection or communication between the end user and the site. Okay, so that the data is not compromised whenever we are trying to access that application or site. Okay, so these will be of any type. These certificates, either we can say these certificates will be of type like domain validated certificates or organization validated certificate, extended validated certificates. These are different types. We'll see what are these types in future, but for now, for the time being, we can say that these all the types are part of the SSL TLS or web certificates. Okay. Now we have the email security. So the certificates which will be used to uh, secure the communication for emails. Now, what I mean when we are saying the securing the communication in emails. Okay, so if I have some confidential data that I want to send to someone who is, I just have a couple of intended recipients. Okay, so then what I will do, I will encrypt that email. Okay, when because the data is confidential, I'm not gonna send the plain text email. I will just encrypt that mail the with my certificate, my encryption certificate, and the recipient's encryption certificates. Those details will be already available in the Outlook. That is bit advanced part. We'll discuss it later. But for the time being, just consider this as whenever I'm trying to send an encrypted email to someone, I will my Outlook will encrypt that mail using the certificates of that recipient, and only those intended recipients will be able to read that mail. Okay, so that is the beauty of the email certificates, or we call them as SMIME certificates. Those will be a type of user certificates only, just in encryption parts. Okay, so what are those? We'll see in details in coming sessions, but we will encrypt the emails using the certificates, and uh, the best part is even if the recipient who is the intended recipient, he can or she can open that mail, but if they forward that mail to someone else, they will not be able to open that mail because it's an end-to-end encrypted email in between the sender and the intended recipient only. Okay. Now then next are the code and document signing certificates. So code signing certificates, most of the folks use it, but they don't know that this is a certificate. Okay, so whenever a developer is creating a code, they will digitally sign that code, okay, that I am the owner, the intended person who is the owner of that code will sign that, will timestamp that, that this is my code, I have written it with the dates and times and everything, which will help other folks to uh, authenticate that, like not authenticate, I can say they will they will be able to get to know that yes, this is the actual code which is developed by that person and it is signed so that it's illegitimate. Okay, and it prevents the integrity. So someone is making some changes in that code and they are going to post it again, but they will not have that signature of the original author. Okay, then we can bifurcate that this is the original code, or this was the original file uploaded by the owner, and this is the modified file, this is the altered data. Okay, so we can bifurcate using that. So those are the code signing certificates. And then we have document signing certificates. Okay, so document signing certificates are similarly working, or we can say it's an equivalent to code signing certificates only, but here we just digitally sign the documents which are created by us. Okay, so ensuring their authenticity and non-repudiation. Authenticity, we know that yes, I am the owner of that document, and non-repudiation means no one can say that yes, this document was not what we say. Yeah, this document was not created by that person, or someone cannot replicate it, saying that yes, this document is not bel- it it is not belonging to that person. Okay, whoever has signed that. Okay, so no one can say that is the reason we use the document signing certificates. Okay, so we use it every time. Whenever you are using any document viewer, there will be an option to sign the document, and it will be using the certificates. But we just simply click on sign the document, and it will get amended, the certificate will get amended, or digital signature or document, this our signature will get amended, but we don't know that yes, that is the work of the certificate. Okay, so those are the document signing certificates. And yes, now we have two types of certificates. So all these categories which we have discussed, those will fall with these self-signed versus CA-signed certificates categories. Okay, so what are the self-signed and CA-signed certificates? These are the only two types of certificate getting the certificate issued. Okay, so self-signed certificates are the certificates which are issued by itself. So as we discussed, that root certificate is a self-signed certificate. So suppose I am generating a certificate and I'm signing it by myself. Okay, or the certificate which I am issuing, I am signing that certificate with itself. That is a self-signed certificate. Okay, it means that they are not issued by a third-party authority, or they are not issued by a trusted source. They are just signed by themselves. Okay, so they are used of, like, we don't use self-signed certificates in an production or the customer facing sites. Okay, these are just for testing purposes or internal purposes during the development or testing phases. Okay, so we use these certificates where there is no concern of security, not integrity, not confidentiality, or not data breaches. Okay, so no trust required, we can use the self-signed certificates. Okay, but usually these are not recommended. These are recommended only in testing environments, so that there will be no uh, uh, data, well, there will be no issues with the data security or the integrity. Okay, and then we have the CSIN certificates. So CSIN certificates are the certificates issued by certificate authorities. Okay, either by internal external authorities that we will see in the coming slides. So these certificates are trusted. Okay, so these certificates are signed by a trusted authority. Okay, and those will be recognized. Okay, those will be recognized and validated, and these will be available on the operating systems worldwide. If I say the public certificates in the science certificates, those will be available in all the machines, like most of the machines worldwide. Okay, and these will be used for the public facing sites or the internal sites as well, where we need to secure the data and secure the integrity of that data. These will be used. Okay, so whenever we have some critical systems, we use CSIN certificates. And if we have just the testing environments, or we just have a non-critical environment where we just do some developments or internal tests, we will be using self-signed certificates. But 99.99% of the critical websites or the internet-facing websites, the CS signed certificates will be used. Most of the browsers don't even support the self-signed certificates. Okay, now as we discussed in the CSIN certificates, we'll be having two categories. First will be public certificates, and another will be the private certificates. So, what is the public certificates? Okay, so public certificates are the certificates issued by public CS like DCert, Sectigo, Global Sign, or Let's Encrypt. Okay, what does that mean? So, these public CAs will be trusted by all the computers or machines, or we can say the operating systems as well. So whenever, suppose I am installing an Windows operating system in my machine, then whenever that Windows OS is getting installed, all these public CS certificates like intermediate certificate and root certificates will be there already. Those will be already trusted on my machines. Okay, because these are the public certificates. Okay, now so now what are the use cases? Okay, so all the public facing sites. What I mean by public facing sites is whenever, suppose I'm creating a site and I want all the people in the world who are accessing the internet should be able to access that site. Okay, and to secure that site, I will have to use a public certificate, public or external certificate we call it. Okay, so if I'm using that certificate, then all the people who are using an internet, if they browse that site, they will be able to access that site securely because their device will be having the public CAs already, or public CS certificates already present on their machines, because those are the public certificates. Okay, that is a use case. That is the most important thing that public certificates are used for. Okay, then we have the trust model. Okay, so the public certificates, as we discussed, that these will be trusted by all the operating systems in the world. Okay, we are saying all major, but yes, nearly all operating systems in the world will be having the trust already built in their machines. Whenever the OS is installed, we will be having that trust built already on those operating systems for these public CAs. Okay, these are just examples of public CAs, but there are more, and all will be having their trust already built. Okay, now what about the costings? Because the certificate will also have the cost. These may be free. Okay, there is only, I guess, one CA which provides the free public certificates, but all other will be having some cost associated with it for a year. So we will get charged for a year for the public certificates. Maybe it's whatever type of validation it have, it will have some cost with it. Okay. And what are the examples? Like suppose I am accessing www.google.com or youtube.com. Okay, it will be issued by a public CA and it will be trusted in all devices, and that is the reason that you are able to access that site. So if my device is not having any trust for Google certificates, if I say the Google trust chain, I'm not having those in my device, then I will not be able to access any site affiliated with Google. Okay, so those are the public certificates. Now if I move to the private certificates, so what are these private certificates? Okay, so these are certificates designed to use within the organization or within an enclosed loop. Okay, if I say, suppose having I am having an organization. Okay, and I want some sites or some servers only to be accessed by the employees of that organizations. Okay, then I will set up an private certificate authority. Okay, or internal authority, I will say, and those certificates or the trust chain of those certificates will be there in my organization. So my organization's people will be able to access that, but anyone outside the organization will not have that trust built, so they will not be able to access that site. Okay, now what are the use cases? Securing internal servers, devices, or Wi-Fi's, VPNs, smart cards, and any other systems. Okay, so when you are going to your organizations, internal organizations, and you are accessing something internally, like your servers or uh, your internal applications, okay, which are accessed only internally, those will be having the private certificates. These are more secure, uh, secure in the sense that nobody who is not supposed to view that site or view that application will not be able to access that because they don't have the trust built in their machine. Okay, your device will be having those trust built already because your organization will have that uh, issuing and root CS certificates already stored in your machines, and using that trust chain, whenever you are trying to access something, the trust chain will be validated and you will be able to access that site. Okay, now the trust model for that is it will be not trusted outside your organizations. Okay, so when suppose I'm working in Google, we have some internal applications, those are only accessed by Google employees, and someone from outside, like from Microsoft, someone is trying to access that, they will not be able to access it. Okay, because they don't have the trust built in their uh, machines. Okay, if they want to access it, they will have to manually install the root, intermediate CAs and everything. They will have to build that trust, and they will able to access that. Now, what is the costing? So these will be free. Free in the sense the certificate costs will be free because it's totally internal, but we will have to set up an entire PK infrastructure for that. So that cost will be there, one-time cost, but the issuance cost will not be there. And what is the example? Now, suppose the Google example, I can say that Google has some internal database servers or internal applications that are accessed by only the Google employees. Those will be having the internal certificates in their stores, okay, in their machines. Now, some uh, the the feeds of the public certificates and private certificates, and what are the difference? Okay, the public certs will be issued by public CAs, internal will be with private or internal CAs. It will be public certs will be trusted by everyone. The private certs will not be trusted by everyone, or if we want to trust those, we'll have to do it manually on the other systems. The use cases will be public websites, softwares, emails. For private, it will be internal systems, device, VPNs, or Wi-Fi's. Visibility of public certificates will be globally, but for private, it will be the limited to set of peoples. Public certificates will be most probably paid. Just in some cases, it will be free, but private certificates will be free, but there will be an one-time infrastructure or maintenance cost. Then the validations for the public certificates will be domain, organization, or enterprise validations. What are those? We'll see in later sessions. And for private certificates, it will be only related to organization validations policies because those will be accessed by some certain set of peoples only. Okay, so these are the details of a certificate. Now, as we discussed in start, that we will discuss an live example of a certificate. Okay, so suppose I will just open a site. Okay, now I have opened an site for Microsoft. Okay, now here when I am checking the arrow symbol here in our web page, we can see connection is secure. That means this site is HTTPS. Okay, now if I open the site, just check the site, it is HTTPS. That means it's a secured. So when I go to the symbol here, you can see either lock symbol or this arrow symbol, where you can go, you can check connection is secure, and then you can see certificate is valid option is there. When you click here, you will be able to see the certificate, which is securing the site. Okay. Now, what I will do from here, it's a bit hard to uh, check all the details. So I will download this certificate. It's publicly available, so we can download this certificate as well. And I will just download, I will just save it, and now I will open that certificate. Okay, now give me a second, I will open that certificate. It was not downloaded properly. Yeah, now Yes, now I have downloaded certificate. Now I have just opened that up for viewing the details. So this is how a certificate looks like. Okay, so now, okay, so now I have downloaded that certificate on my machine, and this is how a digital certificate looks like. Okay, so we can see that I was accessing this Microsoft.com site, and I downloaded a certificate for that site, and it says it is issued to Microsoft.com. Okay, it is issued by this is the issuing CA, and it is valid from August 26 to 21st of August 2025. Okay, so these are the general informations. Okay, now I'll go to the certification path first. Okay, so when we discuss the root and intermediate certificates, you can see this is the leap certificate, which is for www.microsoft.com. We have the issuing CS certificate as Microsoft Azure RSA issuing CFO. That is the issuing CS certificate, and we have the DigiCert Global Root G2. That is an root certificate. Okay, so this is a trust of chain which is already there on my machine. That's why we are able to see this. Okay, now if we go to the details of certificate, so these all are the fields which are present in a certificate. Okay, we will see all those fields one by one. Okay, so first is the version. The current industry standard is version 3 for all the certificates. That's why we can see here it's written as version 3. Then we have the serial number, which will be unique for each and every certificates. Then we have the signature algorithm. Signature algorithm means with what type of algorithm the certificate is signed. Okay, so it's SHA-384 RSA. What's that? We will see in details in coming sessions. Then we have the signature algorithms. So signature hash algorithms. Then we have the issuer. So we can see here the issuer is the one which we saw in the certification path. Now then we will be having details like validity from when it was issued and till what time it will be valid. Then we have the subject. Okay, so in the subject we will have the details like what is the name of the certificate, common name of the certificate, that will be Microsoft.com. What is the organization? That will be Microsoft organization or Microsoft Corporation. Then we will be having the locality, state, and the country. Okay, these details will vary as per your localities and as per your organizations. Okay, now when I go next, we will be having public key parameter. It the minimum requirement nowadays is 2048 bits. Okay, so this is the public key. We have public key parameters. Okay, then we have the SCT lists, the policies which are defined for that certificate. Those are here. Then what is the template? Certificate template. So for the just time being, remember that whenever certificate is issued, it will be issued with certain template. What are those? We'll discuss in coming sessions because that would be too much for right now. Then we have the authority information access. So these will give us details, or these will verify that the issuer of that certificate is legitimate or not. Okay, so that is for, we call this as AIA, authority information access. Then we have the subject key identifier that will be also used for identifying the certificate which is issued, is it legitimate or not. Okay, then we have the subject alternative names. So this is one of the important fields that is in the certificate. It will contain all the names of the sites that we want to access using a single certificate. So if I'm issuing a certificate for my name and I want to access all other folks name as well in that certificate, I will just include those in DNS names. Okay, and that certificate can be used for that sites as well. Then we have the CRL distribution points. So this is one of the major, I can say major attribute. Okay, so using this, we get to know that if this certificate is valid or it's revoked. So the legitimacy of this certificate would be discussed using the CRL distribution points. Okay, we'll we'll discuss all these topics in depth uh, in coming session. But for now, just uh, remember that, or uh, just get to know that these are the points or these are the attributes which will be there in the certificate. Then we have certificate policies, like the policies which will be defined for a certificate. Then we have the AKIs, authority key identifiers, with with this ID we will be able to identify. So suppose I open an intermediate certificate now and I see the SKI of that certificate, the subject key identifier. It should be similar as this authority key identifier for this certificates. Like how it works, we'll discuss later. Okay. Now then we'll be having the key enhanced key usage. So for what purpose the certificate will be used. Then key usage, this will be like granular level for like what purpose will be our certificate. So here it is like key encipherment and digital signatures. Then we will be having the basic constraints and thumbprint. Okay, thumbprint is also like what we can say the serial numbers. It will be unique and we can identify the certificate using the thumbprint as well. Okay, so this is a certificate and how it looks like. Okay, now if I uh, this site is having HTTP, yes. So now if I just try to access site without a certificate, okay, it should not be accessible. Okay, but now it is accessing the site because it's automatically logging in the yes. It's appending the yes. Even if I am removing the yes, it will not go. It will always show the HTTP yes. Okay, so this is the use of certificates. Okay, so now I guess this is all for this session. We will discuss like what are the certificates, types of certificates, the uses and everything. So in the next session, we will discuss the attributes in details which are there in the certificates and what are the uses of those attributes with examples, I guess, with the same certificate which we have downloaded today. Okay, so I guess that's it for today. See you in the next session.